Hello everyone, welcome to Blink 2.0 series of video. This is Bhupender Singh and today I will show you how you can make a TDS sensor based safe water quality meter using TDS sensor with Blink 2.0 IoT Cloud. As per the study, total dissolved solid means TDS value part per million ppm is between 150 to 250 for safe drinking water and poor is between 300 to 500 ppm, and for electrical conductivity EC value should not exceed 400 micro square per centimeter. This methodology is also used to measure the quality of RO water. So guys, for this project we use following components: Nutify Wi-Fi or NodeMCU module, TDS sensor, DS18B20 waterproof water temperature sensor, connecting wires and breadboard. This is the circuit diagram where you can see red color wire denote to 5 volt DC power supply, blue color wire denote to ground, and orange color wire denote to 12 volt DC input to Nutify board. You can also provide external power to Nutify or NodeMCU via USB cable. We use the TDS sensors data pin to A0 pin of Nutify and data pin of temperature sensor to D5 number pin of Nutify. We connect the 4.7K resistor between the data pin and the 5 volt VCC pin of temperature sensor as shown in the circuit diagram. And this is Nutify Wi-Fi IoT board designed by Nutty Engineer Company. You can also use NodeMCU. This is a DS18B20 waterproof water temperature sensor having 3 wires. Red color wire is 5 volt DC power, yellow color wire is data, and black color wire is ground. We use 4.7K resistor between data and VCC wire for reference as you can see in circuit diagram. And this is TDS sensor by which we can calculate the TDS as well as EC electrical conductivity value for safe drinking water. As you can see, here are 3 output pins. The first pin is ground, second pin is 5 volt VCC, and third pin is data pin. Now we need to open the browser and open the Blink Cloud website. Here, if you are a new user, then create your new account, otherwise login by your credentials. After login, you can see the dashboard of Blink. Here you can create your first project template. So click on the new template and you will see the template property. Here you write your project name. Below, select hardware as ESP8266 and connection type is Wi-Fi. At the description, write your project description and click on done. Once you have done it, you will see the info tab where you see firmware configuration of your project. This is important because we need to write it in our Arduino program. In the meta tab, we see the information about our project we just created. In the data stream tab, we define the method of accessing the Nutify board like analog, digital or virtual. Basically, we go through the virtual pin as it has many advantages. We will discuss it in our later videos. Let's define the virtual pins. So click on the new data stream and choose virtual pin. Virtual pin property gets opened. Write the name as temp C, virtual pin as V0 and data type as double, and maximum temperature value set to 100. Set the unit to Celsius and click on create. Similarly, we create another virtual pin. Click on the new data stream, then virtual pin. In the property, write the name as temp F means Fahrenheit. Select the pin as V1, data type as double, and maximum value for this to 150 and unit as Fahrenheit and click on create. Create another virtual pin for TDS value. Click on new data stream, then virtual pin. In the property, write the name as TDS, virtual pin as V2, data type as double, and maximum value to 500. Select the unit as part per million and click on create. At last, we create the virtual pin for electrical conductivity. So click on the new data stream and then virtual pin. In the property, write the name as EC US square centimeter, micro square per centimeter means pin as V3. We leave the unit as it's not available in the unit section in the blank. Set the maximum value to 400 and click on create. Finally, we have created the virtual pins for all parameters. Now go to the web dashboard. We drag and drop 4 labels for each virtual pin that we have created. Now hover the mouse cursor on label and you will see the setting icon on the label. Click on that. You can see the property of the label. Select the data stream as temp C V0 and click on the save button. Now go to another label and open setting. Select the data stream as temp F V2 and click on save. Now click on the third button and open setting. Select data stream as TDS PPM V2 and click on save. Last fourth button, click on setting and select data stream as EC V3 and click on save. That's how we can create the label on the web dashboard. You can also see the demo values for labels here. Now click on save button to save the changes in template. In the mobile dashboard, you can download the mobile app for your iOS or Android mobile. Now it's time for the programming code of Arduino. So go to the video description and click on the link given to download the programming code for TDS water monitoring. Once downloading is done, you will get the WinRAR file with the name TDS sensor with Blink 2.0. Right click on the folder and click on extract here. If you don't have WinRAR or WinZip software to unzip it, then a link is available in the video description to download the software. Once it's unzipped, you will get the folder with the same name TDS sensor with Blink 2.0. Go inside the folder and open the program file with the same name as TDS sensor with Blink 2.0. So this is the program for TDS sensor. Top of the program, you can see the blank credentials. You need to replace it with your blank template. So go to your blank dashboard. In the info tab, you can see the firmware configuration. Copy these credentials and replace it with Arduino code. Here we define the blank firmware version. In the next line, we define the blank serial, and in this line, we define the NodeMCU version. Here we include the blank agent.h library. We define the data pin of temperature sensor as an integer type to D5 pin of Notify and data pin of TDS sensor to A0 pin of Notify. Here we take A RAF means A reference to 3.3 as the voltage level of analog pin in Notify or NodeMCU is 3.3 volt. We define EC val to 0 for electrical conductivity, unsigned integer TDS value to 0 to store the TDS sensor data, and float type EC cal means EC calibration compensation to 1. We have created a separate function to calculate the sensor data and send them to blank server. So we take WTemp as double to store the current temperature. Here we multiply the conversion accuracy of the sensor to 0.0625 lbs. Here we take V level for the analog pin of Notify to 3.3 volt. So we divide the 3.3 volt by 1024 to match the level of the analog sensor. Here we calculate the raw data of electrical conductivity by multiplying input analog data with V level. Here we calculate the temperature coefficient 1 plus 0.2 into WTemp minus 25. It is an algorithm to calculate the temperature coefficient. Now we calculate the EC value by algorithm rho EC upon T coefficient into EC cal. Now we calculate the TDS value by using the algorithm. We convert the temperature to Fahrenheit by the formula temperature into 9 upon 5 plus 32. Now we have all the data that is required. We will send them to blank. So first we print all the data serially one by one. First we print TDS value, then EC value till 2 decimal places, then water temperature in Celsius and Fahrenheit with 2 decimal places. Now we send the water temperature in Celsius in the blank V0 virtual pin by writing the blank.virtualWrite command, as we have defined the V0 virtual pin in data stream in the web dashboard of blank. Similarly, we write the command for temperature in Fahrenheit to V1 virtual pin, TDS sensor value to V2 virtual pin, and EC value to V3 virtual pin of our blank template. Now come to the setup mode. We serially begin the serial data to 9600 baud rate and begin the blank agent by using blankagent.begin command. This command is responsible to connect your Wi-Fi board to blank server. We have given the delay of 2 seconds by defining delay 2000, so that once it is connected to blink, it will take 2 seconds to start the timer to send the sensor data to blink. This is the timer function that is responsible for sending the sensor data to the server every second by calling the send sensor function that we have defined here. In the loop function, we run the blank agent.run function to call all the blank functions by external software interrupt. At last, we write the timer.run function to execute the timer.setInterval to send data to the server. So this is how our program finished. Now we need to add a library of blank to our Arduino IDE. So go to the video description and download the library. Once downloaded, you will see that you got the zip folder with the name blank library master.zip. Now right click on the folder and click on extract here. As you can see, all the files have been extracted to the folder with the same name as blank library master. So copy this folder and go to the place where you installed the Arduino software. Go inside it and you will get the folder with the name library. Go inside this folder and paste the library here. Now it's time to upload the program to Notify. Connect the Notify to the computer's USB port. Here we select the Wi-Fi board to upload the program. So go to the tools and click on board and select the NodeMCU 1.0 ESP12E module. If you don't know how to install the NodeMCU Wi-Fi board to Arduino IDE, then a link is available in the video description that will show you how you can install Notify NodeMCU to Arduino IDE. After selecting the board, go to the port and select the COM port as COM8. After that, click on upload. Here you can see the program is uploaded to board and it's done. Now time to configure the Blank mobile app. So go to the App Store and search for Blank. You can see we got the two Blank apps, Blink Legacy and Blink IoT New. We need to install the Blink IoT New. As I have already downloaded it, so open the Blank app and you can see we have got the two options, sign up or login. As we already created an account with Blink, so login to it. And for Android user, they can download it from the Android store. Dashboard has been opened. We always remember that the developer mode option must be on in our app. So go to the profile and open it. As you can see, by default it's on. So go back to the dashboard and click on the add new device. Here we got three options: connect to Wi-Fi, scan QR code and quick start device. So we select connect to Wi-Fi and the next screen has been appeared. Here we need to power up Notify and click on ready. As you can see, we have got the pop-up with Wi-Fi name starting from Blank. Click to join and please wait here. I have got lots of queries on this step. Few people didn't get any Blank device while adding new device. So for them, they need to go to the Wi-Fi setting of your phone and search for new Wi-Fi. Once you see any Wi-Fi with name start from Blank, then join that and back to the app and click on ready. Automatically it will add that device to your app. Okay, as you can see, it gathers the device information. It's asking to join a Wi-Fi network so that it can use that network to connect with the Blank cloud. Yeah, it's already remember my Wi-Fi credentials. But for you, provide the credential for the Wi-Fi and click on continue. Now it is configuring the Wi-Fi network. Click on continue and then done. Now exit from the app, back to the main dashboard of the Blank. You got your Blank project here that we have created in our Blank web dashboard. Now click on the project and click on the setting icon. Inside it, click here and scroll below. Click on the value display widget. We add 4 widgets to the dashboard as we are displaying 4 data. We can move the widgets as per our requirement and also resize it by long press on the widgets. Now click on the first widget and its property gets opened. Select the data stream as temp C V0 and change the font size to auto and back to the dashboard. Now click on the second widgets and select data stream as temp F V1 and change font size to auto and back to dashboard. Click on the third widget and select data stream as TDS PPM V2 and change font size to auto and back to the dashboard. Now click on the last widget and select data stream as EC V4 and change font size to auto and back to the dashboard. So this is how we can configure the Blank 2.0 app. As you can see, it's displaying the demo data to show how the preview of data here. So time to connect the hardware. We take the temperature sensor and connect the data pin of temperature sensor to D5 number pin of notify and ground pin to ground. As we have only one 5V pin in notify, so we take one male to female wire and connect the 5V pin to breadboard so that we can provide the 5V VCC to our TDS sensor. We take male to male connecting wire and connect the temperature sensor's VCC pin to the breadboard voltage pin. Now we take the TDS sensor. Here we take female to female wire and connect ground pin to notify ground pin. We take male to male connecting wire to the VCC pin of TDS sensor and connect it to the 5V of breadboard. Now we take one male to female wire to data pin of the TDS sensor and connect it to the notify's A0 analog pin. Our hardware connection has been done successfully. Now I am connecting the USB cable to notify and connecting it to the computer's USB port. As you can see, the board has been powered up. Now we take a glass of water to check the water quality. First, we dip the TDS sensor in the water and then the temperature sensor. Let's open the Blink mobile app. As you can see, our app is offline as notify is not online yet. It will take 5 to 10 seconds to come online. Let's refresh it. Oh, that's great. It's online now. Click on the app and you can see the temperature in Celsius and Fahrenheit as well as the TDS and EC values. But guys, you can see TDS ppm value is very poor, means 386. As per the WHO study, this water is not safe to drink. So this is how you can design your own IoT based water quality meter for safe drinking water for your home or your industry using Blink 2.0. If you are looking for any kind of help for your research project, for your industrial product or as an hobby, whether it's to design your PCB, any kind of hardware like IoT gateway, edge devices, add-on devices or any RF network devices, I am ready to help you. You can contact me. All the information and links related to the video available in the video description. You can download it from there. Thanks for watching. Kindly like, subscribe and share our channel and videos.